Greetings, cosmic voyagers. It's your host, HB, and today we're venturing into territories that stretch the very fabric of what we call reality. Have you ever paused, mid-thought, and wondered if there's more to existence than what meets the eye? The idea of parallel universes, once relegated to science fiction, is finding intriguing footholds in theoretical physics. Imagine countless other universes, perhaps similar or unimaginably different, each playing out its own cosmic drama. It's a thought that's both exhilarating and humbling, challenging our view of the cosmos. So, buckle up your curiosity. We'll delve into quantum mechanics, string theory, and cosmic inflation. Let's begin with one of the most established, yet utterly perplexing, ideas stemming from quantum mechanics, the many-worlds interpretation. Picture the subatomic world, a realm where particles like electrons don't have definite properties until they're measured. Before measurement, they exist in a fuzzy state of all possibilities, a superposition. The many-worlds interpretation proposed by Hugh Everett III offers a radical solution to what happens at the moment of measurement. Instead of the particle choosing one state in our universe, the universe itself splits. Every quantum event, every tiny decision point at the most fundamental level, causes reality to cleave into multiple parallel universes. In one universe, the particle spins up, in another, it spins down. And these aren't just ghostly possibilities, they are all equally real, coexisting branches of reality. Now, extrapolate this. If this happens for every quantum event, and there are countless such events happening every microsecond throughout the cosmos, the number of parallel universes becomes unimaginably vast, perhaps infinite. Think about your own life. Every choice you've ever made, from what you had for breakfast this morning to major life decisions, could have, according to this interpretation, spawned a new universe where an alternate version of you made a different choice. There could be a universe where you took that job offer, another where you pursued that relationship, another where you zigged instead of zagged. Each of these yous would be convinced that their reality is the only one, just as you are now. The sheer scale of this is difficult to comprehend. Now let's shift our focus from the quantum realm to the very structure of space-time itself, with string theory. String theory proposes that the fundamental constituents of matter are tiny, vibrating strings. The way these strings vibrate determines the properties of particles, like musical notes. For string theory to work, it requires more dimensions than we experience. These extra dimensions are compactified, incredibly small. Imagine a garden hose. From a distance it looks like a line, but up close you see its surface. Our universe could be a three-dimensional brain within a higher dimensional space. Let's inflate our perspective with the concept of bubble universes, born from cosmic inflation. Inflation suggests the universe underwent rapid expansion after the Big Bang. This explains the cosmos's flatness and uniformity. Eternal inflation means inflation didn't stop everywhere simultaneously. Imagine the early universe as a seething ocean of energy. In some regions, inflation stops, forming bubble universes. These bubbles expand, creating universes like ours. The surrounding space continues to inflate eternally. Our universe could be one bubble in an infinite multiverse. New bubble universes form constantly, like bubbles in boiling water. Each bubble could have unique physical laws and constants. This is a mind-boggling picture. Imagine an infinite cosmic foam, each bubble a universe. Some might be similar to ours, supporting life. Others might be radically different with exotic physical laws. Let's explore the Mandela Effect, a phenomenon where many people share false memories, named after the false memory of Nelson Mandela dying in prison in the 1980s. Other examples include the Berenstain Bears and Darth Vader's famous line, "Scientifically, these are errors in memory, amplified by the internet," but some speculate they are echoes from parallel realities. Could these shared false memories be faint echoes from alternate histories? Let's delve into one of the most philosophically provocative ideas linked to the many worlds interpretation of quantum mechanics, quantum immortality. This isn't about living forever in specific timeline in the way we typically think of immortality. Instead, it's a thought experiment that explores the subjective experience of consciousness if the many worlds theory is true. Consider a scenario, often dubbed quantum suicide. Imagine a person in a sealed room with a device linked to a quantum measurement. If a particle is measured to spin up, a gun fires, killing the person. If it spins down, the gun clicks harmlessly, and the person survives. According to many worlds, each time this experiment is run, the universe splits. In one branch, the particle spins up, the gun fires, and that version of the person dies. In the other branch, it spins down, the gun clicks, and that version survives. Now here's the crux. From the perspective of the conscious individual, they will find themselves in the branch where they survive. Why? Because consciousness, by definition, cannot experience its own termination. If you die in one branch, your stream of awareness simply ceases in that reality. Our final theory blurs the lines between physics, philosophy, and computer science, the simulated multiverse hypothesis. This idea posits that our reality might be an advanced computer simulation, created by a far more advanced civilization. Think the Matrix, but much more sophisticated. Philosopher Nick Bostrom argues that if advanced civilizations can create simulations, they would create many. Thus, simulated realities would vastly outnumber the base reality. Statistically, it's more probable we are in a simulation. This opens up a new way of thinking about parallel realities. We've journeyed through some of the most mind-altering theories the human intellect has conceived, from the quantum foam of many worlds to the digital echoes of simulated realities. Each of these concepts, whether rooted in complex mathematics or intriguing patterns of human experience, pushes the boundaries of our understanding, challenging us to think beyond the familiar confines of our single, perceived universe. The cosmos, it seems, might be infinitely more layered, more diverse, and more wonderfully strange than our ancestors could have ever dreamed. These aren't just idle speculations, they represent humanity's relentless quest to comprehend its place in the grand scheme of things. They force us to confront the limits of our knowledge and the vastness of what remains unknown. Whether it's the idea of infinite versions of ourselves living out every possible choice, or our entire existence being a sophisticated program, these theories invite us to look at the night sky, at our own lives with a renewed sense of awe and profound humility. The universe doesn't owe us simplicity. The quest for answers continues, driven by that insatiable human curiosity. Perhaps one day, we'll find definitive evidence for one of these theories, or perhaps new, even more bizarre ideas will emerge. Until then, we can ponder the possibilities. If even one of these theories is true, reality might be way stranger than fiction. Which one do you believe in? Comment below. And as always, keep looking up.